Hello there guys, I hope you're doing well. In this video I want to teach you the properties of sigma algebra. But before watching this video, make sure to like, comment, and subscribe to my channel so you can see more content from me in the future. Now let's go to the properties of sigma algebra. If you haven't already watched my video on the definition of a sigma algebra, I put the links here so you go and watch it. But for now, as we know, sigma algebra has three main properties, which is it's closed under complement and it's closed under countable union. And also, as you know, the set itself, an empty set, is also in the sigma algebra. These properties that you see here are the properties that are derived from the main properties. So these are not the main properties. So if you had a set and you want to check if it's a sigma algebra, you got to check the main properties. The first property that we can derive is the closedness under countable intersection. As we saw in the properties of sigma algebra, it's closed under countable union. Okay, so if we have a sequence of elements of F, then their countable intersection is also in F. And the reason is every element that you choose from F, its complement is also in F. This is the second property. So from the third property, the union of complements of A sub i's is also in F. And from the second properties, the complement of this union, which is the intersection of A sub i's, is also in the sigma algebra. Okay, now let's go to the second property, which is closedness under finite union. Well, if you remember, we told the sigma algebra is closed under countable union. But we have here finite union. Finite means it ends somewhere. It ends at n. So if we have like A sub 1, A sub 2, all the way to A sub n, which are an element of sigma algebra, we want to prove then their union of A sub 1 all the way to A sub n is also in F. Well, in order to prove this property, we can choose A sub n plus 1, A sub n plus 2 to be empty set. And the reason to do this, because we know already empty set is in the sigma algebra. So the finite union of A sub i's is going to be A sub 1 union A sub 2 all the way to A sub n. Again, A sub n plus 1 union A sub n plus 2 union. Well, then the finite union is going to be like the countable union. And we know from the third property of sigma algebra, the countable union is in the sigma algebra. So we can say the finite union of elements of sigma algebra is also in the sigma algebra, or it's closed under finite union. The next property is closeness under finite intersection. It's just like the previous property. If we choose A sub 1 all the way to A sub n to be an element of sigma algebra, now we want to prove their intersection is also in the sigma algebra. Well, I want to leave it to you so that you write it in comments, just like the previous case. In the previous case, we chose A sub n plus 1, A sub n plus 2 to be empty set. But here we have intersection. So we have to choose A n plus 1, A sub n plus 2 to be, write it in the comments. The fourth property is the property of closeness under subtraction. If we have A and B to be an element of F, then we can say A minus B is also an element of sigma algebra. And the reason for that is we can write A minus B to be A intersection complement of B, because as you know, A minus B is everything which is in A, but it's not in B. Everything which is in A, but not minus in B, but not in B. Okay? And from the previous property, we saw it's closed under finite intersection, and B complement is also in sigma algebra. From the previous property, A intersection B complement is also in sigma algebra. And the fifth property, which is A delta B, if we choose A and B to be an element of sigma algebra, we want to prove A delta B is an element of sigma algebra. And we know A delta B is A minus B union B minus A, or A union B minus B union A. I'm sorry, minus A intersection B. As we saw from the second property, which is here, it is closed under finite union. So we can say A union B is also in the sigma algebra. From the third property, it's closed under finite intersection. So A intersection B is also in the sigma algebra. And from the fourth property, we can say their subtraction is also in the sigma algebra. So A union B minus A intersection B is also in the sigma algebra. Thank you.